already know one method for solving a quadratic equation. Namely, we solve it like any other polynomial equation, by factoring. So for example, suppose we wanted to solve this quadratic equation. Notice this quadratic equation is in standard form with a equals 2, b equals -7, c equals 6. Polynomial equals 0. How would we solve this? Well, we would factor this polynomial. Notice we need two coefficients whose sum is -7 and whose product is +12. -3 and -4 seems suitable here. And then greatest common factor in this row will be 2x. In this row, -3. What remains here is an x, and what remains here is a -2. -2 times -3 is +6. So our factors are 2x minus 3 and x minus 2. And now using the zero property, we know that if the product of these two numbers is 0, either the first one is 0 or the second one is 0. Let's see, over here we'll add 3 on both sides, divide both sides by 2, and we'll get x equals 3/2 as a solution. Over here we'll add 2 on both sides, and we'll get x equals 2 as a solution. Alright, so that's okay. But what if we wanted to solve this equation? 4x squared minus 7x minus 14 equals 0. In order to factor this, I need to split up that middle term, -7, using two numbers whose sum is -7 and whose product is 4 times -14 is -56. But what are all of the ways we can get 56? We could have 1 times -56, 2 times -28, 4 times -14, and 7 times -8. And then all of those with the signs reversed. But these are the only ways we can get a product of -56. These add up to -55, -26, -10, and -1. -7 is not on this list. Maybe this equation just doesn't have any solutions. Well, wait, no. Because look here. If I look at the graph of y equals 4x squared minus 7x minus 14, I see that there are 2 points where that y equals 0. There are 2 points where 4x squared minus 7x minus 14 is equal to 0. I just don't know what they are. And looking at this graph, it looks like they aren't going to be nice whole numbers either. So our problem then is, how can we solve a quadratic equation when the polynomial can't be factored?